Okay, this is an activity that I've done in my stats classes, and this will be similar to your homework. So you can kind of use this as a guide for your homework. So what I do is I take Chips Ahoy's cookies and I give each student a cookie, and then we write all the number. I have them count the number of chips in the cookie, and I try to tell them, to not use like a speck if there's a speck. But I actually make sure it's a chip. But anyways, we get a group of numbers and then we calculate statistics on those. So, and I'm recording this on my phone. I was going to try to type the answers and do the screen capture on the computer, but I think it'll be kind of hard to do that. So I'm just going to type this. And I started this a few minutes ago and I had a glitch, and I should have done it in pencil so I could erase it because my printer's not working. And anyways, technology is not working with me today, but that's okay. So here are the number of chips in the cookies for 29 students. And so you have to first decide if you have a sample or a population, and this would be a sample because we didn't use the whole pack of cookies. We only used part of the pack. If we had used the whole pack, you could argue that it is a population, or you could argue that some of them still argued it was a sample because it would be a sample of the entire batch. So some data sets, it's kind of hard to, or not hard, but you can kind of argue it two ways. But on your assignments, you should be able to tell pretty easily if it's a sample or a population. So like on your homework for this week, it's very clearly one or the other, and as a hint, it's not this one. So anyways, so we want to find the following and label using the proper notation. So that's why you need to know if it's a sample or a population. So if you looked at the PowerPoint, the different notation means sample versus a population. And you can use the calculator or Desmos. I think I figured everything out for Desmos this time. So you can use one or the other to get these. So we want to do the mean, median, mode, mid-range, range, standard deviation, and variance. So we'll start with the mean. So first off, if you're going to use the calculator, so I have the calculator on the computer, and I've already typed this in just because it took a minute. So you go to Stat and Edit, and here's my list of numbers typed in, 27, 17, 25. So you just type them in, type in a number, hit enter, go all the way down until you get all the way down to your last one. And then, so there should be 29 total. Whoops. Okay, let me try that again. But anyways, and then to find the mean, what you're going to do is you're going to go to, once you're all done, you're going to go to, I usually get out of this by hitting second mode. You don't necessarily have to, but Stat, and then you're going to go over to Calc, hit this button to go over to Calc, and then you're going to choose the first one and hit enter, and it'll give you this information here. So remember, our X bar is our mean because it doesn't know if it's a population or a sample, so it's always just going to say X bar. So if it was a population, you would write mu, but since we are dealing with a sample, we're going to write X bar. So I'm going to put, and I'm going to round this to 3 decimals. So X bar is equal to 19.69. I'm going to round it to 2 decimals. I don't know if I said 2 or 3, but two decimals is fine. The median, it also gives me the median. If I hit the down arrow, it'll say median is 19. And there's no notation for median, so I just write down 19. It also gives me, the calculator doesn't give me the mode. I have to do that myself. I'm going to come back to that in just a minute. Nor does it give me the mid-range, so I'll come back to that in just a minute. It doesn't give me the range. It does give me the max and min, so I can find the max and min using this. So let me write it down while I've got it here. So my range, let me just do the range. Sorry, I'm skipping around, but the max is 33. So if you look here, it gives me the max, so it's 33. Minus the min is 12. And then my mid-range formula is if I add the max and min, then divide by 2. So let me just go ahead and write that down too. And I'll write the numbers in just a minute. And the standard deviation, it will give me the standard deviation it's a sample, so I need to look at S. So this is where you also need to know it's going to give you both. It's going to give you sample standard deviation, the SX, and sigma X, which is the population standard deviation. So we're going to use S because we have a sample. So, and remember this is calculator notation. Proper notation would just to be right. S is equal to 5.298, so 5.3. And my variance is S squared. And instead of doing 5.3 squared, that gives you a bit of an error. So I just type out this number. You can, if you know where it is, go find SX and hit SX and then do squared, but I can never find it. I looked for it a few minutes ago, still couldn't find it, so that's why I just type it out. This gives you less of a rounding error, so we'd have it, make sure I typed that in right, 298,944,964, okay, yeah, squared, so 28.08. And then to go back and fill in my range and my mid-range, I wrote down the maxes and the mins just so we had them. But we have 33 minus 12. I don't know if y'all are like me, but I can do stuff in my head until I'm doing it on video, and then I want to make sure that I'm doubly right so I don't say something silly. So 33 minus 12 is 21. And then 33 plus 12 and divide it by 2. So mid-range, we add max and min and divide by 2. That is 22.5. And so now all I have left is my mode. And so I can go up here and look in this chart and figure out which one's my mode. Or I can also, just to make things a little easy on myself, I can also go to stat and sort, ascending or descending. So sort down or up, it doesn't matter which. I think I usually do sort descending. Is that what I use? Or I can't remember. Seems like I do one or the other, but it doesn't really matter as long as you sort them somehow. And you have to tell it what list to do. I probably do one just as much as the other, but anyway, so I've got them in L1, so I'm going to do second one for L1 and hit enter, and it'll say done. And then if I go back into my list, go to stat and edit, now it has them sorted, and you can go through here and see, so like 14 occurred 3 times, but 17 actually occurs 4 times. And that way, instead of looking at them all jumbled up, they are in order, so you can kind of pick it out that way. So the mode in this case is 17. Some people don't care, they just pick it out up here, which is fine as well, but I just, if you sort it, I think it can help you be faster. So here's all the answers. This was using the calculator. So what I want to do is show you also how to use Desmos. So on Desmos, so if you go to Desmos and do the graphing calculator, which is here, I'm sorry about my computer, screen got cracked a little, or not cracked, but squished. So I went ahead and typed this in. So I don't know if you're familiar with Desmos, but anyways, for Desmos, I'm not familiar with Desmos. It's actually the first time I've really used it a whole lot. Well, not even a whole lot to do this, I should say. So I'm trying to learn in the stats class what it can do for stats. So I define C, since we're dealing with cookies and chocolate chips, is equal to define a list, you do a bracket, and then you just type them all in with a comma. And so here's my whole list of numbers. And then, so it says there's 29 elements in that list, which is fine. And then what you do is you want to go to functions down here. And under stats, it has total and all this stuff here. So I had to look up a couple of them last night. So it has standard deviation. This is for the sample. Standard deviation P is for a population. So if you have a population, you want to click this one. If you have a sample, you want to click this one. I forgot what VAR did. I looked it up last night and I can't remember what it did now. But anyways, so we want the mean. So I want to do the mean of C. So I can just type in C since I have it defined. And it tells me it's 19.69 again, which is what we had. So that's the same that we got on the calculator. You can also, if you wanted, if you didn't define the list, you can type in mean, mean, and then do 27, 17, and type them all in. But if you're going to use it more than once, it's easier to store in a letter variable as a list. Then to do the median, you probably saw here, actually to do the whole 5-number summary, it has it separated. You can do the median, the min, the max, the quartile, but you can actually do stats. And if you do stats and see, it tells you here's your min, your Q1, median, Q3, and max. So, and just to show you on, let's see if I can do it this way. Let me go back to that and do stat, calc, and hit enter, and then scroll down. So this part here, the stats on Desmos, is equivalent to the bottom part of the 1var stats on the calculator. And they match, so that's always a good sign if they both match. So your standard deviation, you go, oops, where'd it go? Here it is. I think there's a little keyboard icon over here. Go click. If you go to function and you're still under stats, you can do, so standard deviation, like I said, the P is for population. The standard deviation of a sample, oops, in the wrong spot here. Let me go down to number 4 here. Okay, let's try again. Standard deviation, and then we still want to do the list, and it is the same again, 5.2989, so I said 5.3 before, so that's the same. And then did it say variance? Maybe that's what, oh yeah, VAR is variance, I think. Let's do it and see if that's what it is. Yes, okay, so VAR is variance. No, I couldn't think of that a minute ago, but variance, so 28.07. So on ours, we had 0.08 when we rounded, which if you round this to 2 decimal points, you'll get 8 bumps up the 7. So 28.08. So Desmos does all of this just like the calculator. Well, not just like the calculator, but it does do it all. So you can use, some of you didn't have a calculator, and so Desmos will work for this, and it's free, and you can find calculators for free too. Some of them look a little sketchy to download, but that's the one I have on mine, is a downloaded free one. So then question number 4 is 10 chips in a cookie unusual? Show your work for the minimum and the maximum usual values. So this is where you take your data value, which is normally x, plus or minus 2 times your standard deviation is your usual values. So my min usual and my max usual are not your x, not your data values. That's not what I meant to say. I meant to say your, I meant to say your mean, x bar, sorry. My mean plus 2 times my standard deviation. And so for my mean, my mean is on the front side there, x bar 19.69. So I've got 19.69 plus 2 times my s is 5.3. Oops, that's the min. I'll get it together here in a minute. That's a minus. And then my max is add. Sorry. So min you subtract, max you add. So if I do that, 19.69, again, I'm going to use the calculator. I don't know if I could do it in my head, if I could do anything in my head today, apparently. Times 5.3. So I've got 9.09 for my minimum value. And then if I add instead of typing it again, I'm just going to hit second enter so I can change that to a plus sign. Oops, hit it too many times. Plus and hit enter. My max is 30.29. So the question is 10 unusual? 10 falls within this range, so no. It is not, because it's between these two numbers. Now if it had asked, like on here, we had a 33, I think. Where's it at? Yeah, here. There's a 33. So if it had asked, is 33 unusual? My answer would be yes, because that would be outside of that range. So since 10 is between these two numbers, it is a usual number. For number 5, you want to construct a box plot of the data and include the 5-number summary. So we did that. I already mentioned it on the calculator. Go to Stat, Calc, 1var Stats, or Desmos under Stats. It gives it to you. So right there's my 5-number summary. So I'm just going to write those down real quick here. So 15.5, median is 19, Q3 is 24, and max is 33. So there's the 5-number summary, which Desmos and the calculator both gave me. And then you can do a number line, and so we need to go between 12 and 33. So I'm going to do like 10, and I guess maybe go up by 5s. So 10, 15. These don't have to be perfect. I'm not very good at drawing, so mine generally aren't perfect. So there's my number line here. So I'm going to draw a box between Q1 and Q3. So 15.5, which is maybe roughly, well, probably went a little high, but that's okay. Roughly there. Usually I mark it so that you know. Up to Q3, which is 24, which is almost here. So that's my box. And then my median is at 19, so maybe about right there. And then I draw a whisker up to my max, which is 33. There's good. And my min, draw a whisker to my min, which is 12, so about right there. And then, so this would be number of chips in a cookie, since we usually title graphs, but on a box plot, sometimes you do, sometimes you don't, if you're just drawing a box plot. But anyways, to follow my rule, I'll title it number of chips in a cookie. So there's my box plot, and then it says find the IQR and list any possible outliers. So my interquartile range is my Q3, which is 24, minus 15.5, my Q1. And like I said, I'm just not going to trust myself at all today. So that's 8.5. And so to do my possible outliers, you have what's called the lower fence, kind of like the max and the min, and the upper fence. So my lower fence is my first quartile, so Q1, which is 15.5, minus 1.5 times my IQR, which is 8.5 there. And my upper fence is my Q3, which is 24, plus 1.5 times my IQR. So similar, they're a little bit similar in formulas, but not quite the same. So now if I do that, I'll get, let's see, the first one is 15.5 minus 1.5 times 8.5. That gives me 2.25. And then the upper one, I do 24, whoops, not 25, 24 plus 1.5 times 8.5, and I get 36.75. So in this case, if I do 2.2, if I have any numbers outside of 2.25 to 36.75, then those would be outliers. In my list here, I don't remember, our min was 12 and our max was 33, so that was, our range of numbers was 12 to 33. All of those fall within that, and so there are no outliers. And so that's done. For number 6, it says calculate the coefficient of variation. So that is our CV. And your coefficient of variation is, I can't remember if the Desmos will just do that for you. Let me click on it. I can't remember what that one stood for now. Oh, no, that's not what that stands. Oh, the COV, that's covariance. So I don't think the Desmos will do that. I think you still have to use the formula. Pretty sure. So to use the formula for that, it is going to be your standard deviation divided by your mean times 100, which gives you a percent. So you do standard deviation, which is, wherever it went, let me write the formula first, I guess. S divided by X bar times 100. So our standard deviation was 5.3. And these, if you use the rounded numbers, that's fine. Normally you'll not, but that's okay. So if we do 5.3, if I do it on this calculator is fine. So 5.3 divided by, so our standard deviation divided by our mean, 19.69, yeah. And then times 100, which is 26.9%. So 26.9%. So that is my coefficient of variation. The last one here, you want to create a frequency distribution of the data using 5 classes and then answer the questions and label using proper notation. So if we're going to do 5 classes, we're going to do our class width, which is our maximum minus our minimum. So you do your maximum, which is wherever it went to, 33 minus 12 divided by 5. So 33 minus 12 is 19, 21, we already said. Divided by 5 gives us 4.2, I think. Yeah, 4.2, and we round up to 5. I had the answers wrote down and I forgot them in the other room there. But so we round up to 5 because you always round up. So we start with our minimum. So we have 12. And then remember, this is where you don't go 5 this way, you go 5 down. So 12 plus 5, surely I can do that in my head, is 17. I'm going to draw plus 5. So you want to do it all the way down. Okay, so 17 plus 5 is 22. Watch me pause, y'all. I don't believe in myself today. 22 plus 5, maybe I need more coffee or something, I don't know. 22 plus 5 is 27. And 27 plus 5 is 32. And then I add 4 or subtract 1, whatever you want to do. So 12 to 16, 17 to 21, 22 to 26, 27 to 31, and 32 to 36. And then for my frequencies, and this is I had wrote down, I forgot it, so I'll have to recount, but between 12 and 16, let me do 32 to 36 first. I think there was only one of those. 32 to, oh, I have my list sorted. That'll be better. Let me do that instead. So if you're using the calculator and you have this sorted, there we go. So between 12 and 16, this makes things easier. So 1, 2, 3, 4, 5, 6, 7, 8. Wait, maybe not make things easier after all. So we got 12 to 16, 8. Yeah, 8. Yes, that's what I wanted. So there's 8. 17 to 21, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. 22 to 26, we have 1, 2, 3, 4, 5, 6, 6. 27 to 31, we have 27, so 1, 2, 2. And then 32 to 36, we have 1. Now, so that was easier, and I didn't try to, whoops, oh, I didn't want to hit that button. Clear that out of there. No, go, I want to delete you. Okay. So I did not try to sort this on the Desmos. I didn't look for sort. Let's see if there's sort. I'm not sure where it would be. So if anybody knows how to sort, they can tell us in the in the teaching tip if you know how to sort on Desmos, because I didn't find that. I didn't look for that. I just now thought of that. But anyways, you can always sort them by hand too and just go through and count. But anyway, so here's my frequency distribution. So now you want to find the mean of that. And this is where, if you use that formula on the PowerPoint, it's like really long, where you find the midpoints of each of these, take the midpoints, multiply it by the frequency, and add them together, and then divide by your frequency. It takes a long time. So what we're going to do is we're going to do it on the calculator. And I also figured out how to do that on Desmos, but only using the formula. So I'm going to go to Stat and Edit, and I'm going to clear this list out. So I'm going to go up, hit Clear, and hit Enter. So my list 1 then is going to be the midpoints of these. I guess it helps if I write them down first. So my midpoint, I'll put it here. So my midpoints, so for 12, between 12 and 16, the midpoint, add them together and divide by 2. And so we should be at, 14, but yeah, I can do that in my head. I don't even know why I started using the calculator, but anyways, 14, and then 17 to 21, the midpoint would be 19. 22 to 26, the midpoint would be 24. 27 to 31, the midpoint would be 29. And 32 to 36, the midpoint would be 34. So that is what I'm going to put in my list 1. So I'm going to type in my midpoint. So I'll show you on the calculator first, and then I'll show you how to do it on Desmos. So 14, 19, 24, 29, and 34. And then I put in my frequency. So I've got 8 and 12 and 6 and 2 and 1. Okay. So then I'm going to go to second mode and quit and get out of there. So to find the median, so again, this is still a sample, so we're still going to, not the median, the mean, we're still going to use x bar is equal to, and it should be close to the first one. It won't be exactly the same, but it should be close. So I'm going to go to Stat, Calc, choose the first 1 bar stats, hit second, 1 for L1, make sure you press the comma, hit second, 2 for L2, and hit enter. And it's 19.86 if you round to 2. And if you look, the mean from the original data is 19.69. So it is close. The decimal's a little different, but it should be close. But remember, you're assuming all the data values are the midpoints in this case. The mode of the frequency distribution is you assume that it's the midpoint with the highest frequency. So that would be 12. So that would be 19. There's no notation for mode. The modal class is you do the class. So that would be 17 to 21. The standard deviation of that is already given me here. It is this SX on the calculator because it's a sample. So we just write S, and that's 5.18. So we'll say 5. Well, I'll write 5.18. That's fine, or 5.19, I guess, since the 7's there. So 5.19, and before when we used the original data, it's 5.3. So it is close. And then for the variance, same thing. We're going to square the S. So I'm going to do 5.187375733 squared, and it's 26.91, and before it was 28.08. So again, it's close. So it is close on using the frequency distribution compared to the original data. And to do that on Desmos, so what you want to do is you want to do 2 more lists. So let's call them A is the midpoint. So A is 14, 19, and I couldn't figure out how to do it using the list notation, like the calculator where you do L1, L2. So I had to do it using the formula. So there's my midpoints. I guess I could have called it M for midpoints, but anyways. For frequencies, we'll do F for frequency. I have 8 So you've got, the A is my midpoints, the F's my frequencies. So the formula is the sum of, let me write it right here. So it's the sum of your frequency times your midpoints divided by the sum of F. So that's your formula. So what we're going to do on here to make that work is total. If you do total, it does sum. Because summation notation on this, you have to put in like, you know, starting out in at 1, running up to 50 or whatever. But anyways, the sum of, you can do F times A. I think, I'm gonna make sure this is how I did it last night, I'm pretty sure. Divided by the total of F, or you could just type 29 since we know that's what it is, but I'm gonna do it this way just to show you. And that is my mean. And so 19.86, which is what we got if I go back. Where'd it go? Oh, no, I did on the calculator. That's what I want to do. I just did it on Desmos. Let me hit stat, sorry. Calc. Okay. L1, L2. Don't forget to do that. So y'all probably think I'm like half crazy, but that's okay. I don't normally try to do it on 2 separate things, but since some people don't have a calculator, that way you can see, or you may find it useful in your own classes when you're doing it. You'll know how to do it both ways. So 19, so the mean using this is the same as this. What I don't know how to do, and I didn't think about that, is the standard deviation for the frequency distribution. Because when you do the standard deviation on here, it won't let me, like if I try to do A comma F or something like that, it doesn't, it'll do A, and I don't think I have the formula for a frequency distribution, and it just tells me that's what it is. So, I guess I lied. I did not figure out everything on Desmos because I can't do the frequency distribution standard deviation. Did I do it on... I don't think I have a formula for a frequency distribution for, I just gave you the formula for the mean. Right, there's probably a formula for standard deviation, which is probably something that looks horrendous because the standard deviation formula itself is horrendous. You would probably use this one somehow. You'd assume they were all the midpoint, so you'd do the midpoint minus the mean squared divided by n minus 1, and you could get Desmos to do that. So I didn't figure that out. So I guess you could do your whole homework on the Desmos, except that last part, unless you want to play around with it and find it. And like I said, maybe somebody knows how to do it, and they can share it with us in the teaching tip. But anyway, so your homework is very similar to this sheet, except like I said, your hint is that it's not a sample. So you'll be looking at sigma instead of S on the calculator. So if you have any questions, please just send me a message and let me know.